Hello, thank you so much for coming. I hope you enjoy the conference so far, and thank you for nice words. So today I want to talk to you about testing in data, and actually not only like share some thoughts and wisdom with you, but actually start a discussion. Because I think there is something we can talk about. Um, so um, a little bit about me. So I'm a software engineer working mostly on backend projects in Thoughtworks, but I'm really passionate about data. So I ask them, please put me on a data project with data people. And once I've got lucky and I joined a team full of data scientists, data engineers, and we did some data analysis together. And it was awesome. I thought, oh, I will learn so much from you. This is amazing. But it was surprisingly that they also learned something from me. And they inspired me for this talk as well. And we thought together that we have a lot of good software practices, which some fields of data are missing yet. So one of them is testing, and we thought that testing is a key for a rigorous, systematic, and reproducible world. So today I will take you to a journey for 4 places. The first one is a disaster city. It's a city of real-life cases because I think that the fear is the best motivator. This is not always true, but let's see. I will scare you with 3 cases where people skipped or didn't do properly testing, and it ended up not being very well. Then we will visit developers' best friends, Happy 3 Friends, TDD. We will talk about this concept a little bit and also how to extrapolate it on a data world, so to say, and if it's even possible, we will discuss it. Then we will be visiting a forest of what-ifs. This is an alternative dimension of a disaster city, so we will check if it's possible actually to have it in other way. And we will end up in a village of tools. I will show you some libraries I found useful or people recommended to me, which we also can apply in a data analysis or data engineering world, or even in data science and machine learning. And I will give you a short example in one of the libraries because we don't have enough time for a lot of examples, but I hope that you will explore these libraries later and probably even share with me your experience. It would be great. And also, this is, here I stored all the sources, so if you don't need to take any pictures of the slides. If you want, you can just go there and then check all the things I've posted in my talk. So let's start with the first disaster. It actually happened a long time ago in 1999. I call it a Mars Climate Orbiter disaster. Mars Climate Orbiter crashed while entering an orbit of Mars. And investigation indicated that it happens because of a mismatch. The units being sent from Earth were pound seconds, and Climate Orbiter expected Newton seconds, the metric standards. So they didn't check the units. So the cost of the operation was $327.6 million from the government resources, from the United States taxes. This is pretty unfortunate. It probably would be covered with one single unit test, I assume. But it was a long time ago. I hope they learned a lot already and will not repeat this mistake. But the second is a little bit more recent. It started around 2000, this whole movement. And then in 2013, a study was published, which I call the Deadly Doctor Study. The study was published in the Journal of Patient Safety, claiming that the medical errors is the 3rd leading cause of death in the United States, causing more than 400,000 deaths per year. And 10% of the population of the United States. And this is not true. So there are some problems, but not so many. And this is just pretty scary when you very catchy header. But analysis was flawed, and subsequent studies shown that This is simply not true. But now on the internet, if you research on it, you will find a lot of headers with medical errors are the third leading cause of death. Beware. Maybe you need to use alternative medicine or something. There are consequences on the studies published without being really tested. So yeah, we will talk about how to prevent it, or maybe how to try to prevent it, at least in the alternative dimension. And now I want to show you the last third example about a company called Zillow. Probably you've heard of it. It was a very the big case that Zillow is an iBuyer, and they relied on an algorithm to purchase homes on a price lower than the market level and then resell them for a price higher than the market level. Very simple, very cool, automatic, quick. What can go wrong? So in software engineering, we call it an edge case. For example, financial crisis or something like this. And they very quickly lost a lot of money on these purchases because an algorithm had an error estimating the prices and sold houses for a price lower than lower than the market. And yeah, so in before they realized what is going on, they lost $308 million. And what is even more sad, that because of this, they laid off 2,000 employees. So 2,000 people lost their job because of this mistake. And not the people who developed the algorithm and deserved, not the other employees, because of the cost. So, and again, I don't want to tell you okay, now I will show you how to prevent all of these cases and everything will be great. No, not really, but I want to discuss how to protect ourselves from this. And maybe if we have this kind of responsibility, probably we can think about some tools which could help us prevent this. And what do we developers have? We have a lot of best practices, but I've chosen this testing one because we discussed it with my team of this data scientists and data engineers. Happy 3 developers friends are this. We call them red, green, and refactor. Probably you all know about it, but if you don't know about TDD, can you please raise your hand? Okay, perfect. So, but it's really quickly to explain. So if you don't know, so you can just know. Okay, perfect. So we can take this approach, test-driven development, and just apply it maybe to a data world like this. Would it be possible? What do you think? For example, I'm doing my data analysis and I'm just writing a test, and then I do my data analysis and then I refactor it. Amazing. No. Unfortunately, it doesn't work like this. I would wish, but we have something alternative. For example, for data science and machine learning, I found this nice maybe I can call it framework, testing sanity and insanity. So if you think about a model, which you can give an input A, and then you can expect you can expect a certain range out of it, right? So something what you expect, you will be getting, and you are sure that the model is not nonsensical in this case. Or you're given it an input B, and then you have a different from the input A output. So you have 2 different outputs, but both of them are expected, and so you prove that your model is not nonsensical. Or for example, you check if your model is well trained. So this is this level of testing, so to say. But we should admit that the client is usually not willing to invest in a solution which is simply not nonsensical. It should they want to invest in something which actually has value. So in order to provide value, so prove that it's even sane or makes sense. For example, if you are choosing for a deep neural network, you should prove that it overperforms the arithmetic average, which in case of when I work with this team, with data scientists and data engineers, we didn't prove them. We just used an average because it was easier, or it was more like, it was better, it performed better for predicting a volume for the next day, for the volume of data for the next day. So sometimes it makes sense, sometimes it doesn't make sense. And if you say, oh, we need like 10 data scientists for this team, so pay them, please, all of them a lot of money, you kind of need to prove that we really need this neural network. But what about, like, this is about data science and machine learning. What about the data analysis? I find it actually the more difficult thing. For this, I have a quote from Sherlock Holmes. It is a capital mistake to theorize before one has data. Insensibly, one begins to twist facts to suit theories instead of theories to suit facts. So that's why it doesn't work like this. You write a test and then you do a data analysis. Unfortunately. But we have something to think about. We have something to derive from this test-driven development. When you divide your analysis you break your analysis into small testable units. And then you test each unit against a set of predefined criteria, which are derived from the analysis, objective, and data quality requirements. And if you argue with me that, oh, probably sometimes we don't have data quality requirements, then I would say, I found this other quote, which belongs to the internet, I believe. Data is like garbage. You better know what you're going to do with it before you collect it. So this is about the data quality requirements. You probably want to have them beforehand. And then this is a generic idea that it will provide a structured framework for assessing and improving data quality and reliability. And your data analysis at the end should be trustworthy and accurate, and the results are robust and reproducible. For the reproducibility, I also will show you a library, which is really cool, which will, with this library, you can create a version control for yourself and also track your data analysis and then compare your results. And really cool. I'm very impressed when I learned about this library. Was very impressed. But still, there are some challenges, I would say. And these challenges, I don't really have an answer of them, but I just want to ask you, actually, how can we overcome these challenges? For example, test-driven data analysis, if we call it like this, requires a specific set of skills. And we all know, especially I've heard a lot, that data people are very, very smart. They're very smart in math. They are very cool in statistics. But sometimes they just don't test things. And that's why they don't have this skill. Because this is just a skill. People coming to Thoughtworks, newbies, they ask me, Anna, I'm a very good software engineer, but I don't know how to do it. It's okay. It's a skill. You will learn it. It's very powerful if you know how to apply it, if you have experience with it. But it's just, it comes with the time. Like a couple of times you do this and then you have it. So I think this is solvable if people have motivation to do that. But also, it's a relatively new technique, this test-driven data analysis. If you Google it, if you Google TDDA, you will end up reading about the Drug Detection Agency or something like this. So it's really probably like one or maybe two libraries which can help you test this. And this is not so popular. But I think the more we talk about it, and that's why I'm here as well, the more we get knowledge about it, the more we develop it. Which leads me to the tools. So it really requires not only knowledge and practice, but a specific set of tools, because it's hard to apply it without the tools. And also as a software engineer, I know that we are happy to develop tools. Just tell us what to develop. Sometimes we don't know, because the data analysis may be not so straightforward. So if we think about testing a web application, it's pretty simple. How to divide it into units, what to do with that. Sometimes it's harder, but actually we develop it for a very long time and it not differs so much, but data analysis does. So probably data people can also navigate us what to develop and how to make it better. And the more also software engineers dealing with the data, as I did, for example, the more we combine this knowledge, we merge it, and then we create better tools. So we're coming to the alternative dimension I mentioned in the beginning. Unfortunately, I only have time for one and a half examples, because first I wanted to show you a picture of the happy climate orbiter, which is alive and happy about the straightforward message. And why I'm showing it to you? Because I wanted to mention property-based testing. So I've learned about it recently, and I found it very nice. That you, for example, if you expect an input for your feature from 1 to 10, and it should behave like it should be a positive case or happy case, and then all others should be a sad case or should behave differently or throw a certain error or whatever, then you should not write like 9 tests for this. You can just set a property. For example, hypothesis library can do this, and you can set a property and it will give an input from 1 to 10. And you can also write another test which can test all other cases, the bad cases. So this is pretty handy. And you can also try it, and then I would be happy if you share your experience with me. But also what I wanted to discuss most is this incredibly bad study, which could be way better if, or in this dimension, we can say they used statistical methods and simulation to really check what they are doing, and if this even makes sense, what they are doing, what you can test your hypothesis, you can prove that it's working. Actually, there are a lot of things which can be applicable for data analysis. They do Monte Carlo simulations. There are just a lot of things which could help you check if it makes sense what you're doing. Also, what is very, very popular at Thoughtworks is this pairing. So in this case, I would say for scientists, peer review is when you're staying on a stage presenting and everyone tries to embarrass you and find what you did wrong in your study. For example, they just read your paper and they say, BS. But also, like, if you just have one person to check if what you're writing makes sense, it would be already great. So, for example, it can be a pair. And they also replicate the study. We would say in this dimension, they would check if the model is accurate. Took the data and they check if the data is not biased, or is there any chance on this results, or is it not? So then replicating would help. And also, you probably know, if you now open like Nature and you see some publications there, this is not always really clear what people have done there. And even if they are like, if the researchers are transparent, you can just take this code, you look at it closely, and you think, how did they even get these results? So from the previous talk, it was something about meaningful transparency. So probably here we also can think about how we can make it transparent for the audience, so that audience can prove that this study or this analysis or this feature, that this is working as it should be working on. Is the result correct? So some experts can prove it, and on the early stage, then they already can say, hey, this is wrong. Don't publish this. And people will not suffer. So yeah, now let's quickly talk about the tools. I have 4 libraries for you. The test-driven data analysis library is the first one. You should not need to take any photos. It's all in the resources. So TDDA is really good for data profiling, testing, and for reference test. One example for reference test I will show you later. It also can be integrated with Python data analysis tools. It's customizable it has customizable reporting. It's really good. The hypothesis one is for property-based testing. A really good one. It generates test data automatically. It can help you generate edge cases. And yeah, it's just nice to try if you do your data analysis or like anything. And the Great Expectations library is even recommended by a tech radar. You're probably aware of this if you are now on this XConf, that we have a tech radar twice a year. And this is a kind of a collective wisdom from the field. So we publish there tools which we use and recommend or not recommend. So this one was recommended by Thoughtworks and by TechRadar. And dbt library is for data models, SQL transformations. Personally, I didn't touch it, but I've heard that this is a very good one and recommended from data engineers. And now let me show you one example. One example from the TDDA library. Let's imagine that we have a web page with superheroes, but we don't want them to be like this and show their real names. We want them to be masked because they are superheroes. Okay, and then we can, for example, I used here TDD because I want to show you how the test fail. It's not interesting for us how it will pass. So let's imagine that we have this awesome protection test, and we're using TDD library and reference test from it. It's like pretty simple. You look at this 16 lines of code. We just open the file we want to transform later, we want to mask. And here when we're asserting this file we want to mask with the file which already masked, so this protected one. So we prepare something in advance with what we want to compare. Or we will automatically get this result if we have a huge file, and we probably don't have this yet, but we have something to compare with. And then if I run this test, I hope it's clear, but if not, let me know. When we run it, we have this output, and this is pretty cool. So it tells us 3 lines are different, starting at line 34. So it will tell us what is the difference. And then we have 2 things here. We have one file written automatically with the raw data, and if we would have processed this data, we would also have this processed file. For now, they are equal because we didn't process it. But if I open one of the diffs, like this, for example, I would have this, and it's pretty clear, like especially for a developer, that in this form. So you will see the difference, but then you can analyze this file as well. You can save it for later. And if you, like me, you will forget in a week what you've done in the week before, then you probably even can open it and see, oh, this was my result. It's amazing. So yeah, if you like, there are a lot of other features in this library. So if you try them, if you find them useful, please give me a message. You will see my email on the last slide, or you can find me on LinkedIn. I would be happy to hear from you regarding these tools. Yeah, and so I have one question for you to take away from this talk. And maybe you want to answer it right now. Can a disaster happen if you're not testing a prototype? You think yes or no? If yes, can you please raise your hand? Okay, so I was talking about testing maybe 25 minutes already, or half an hour, that you should test your things. I actually believe that this is a trade-off always, because if you invest time in testing now for just a prototype, maybe it's not necessary, right? Maybe if it's not a prototype, then you invest more time in debugging it later, right? This is always a trade-off. What I would think, I would probably, if it's just a 1 line of code, I would not test it, if it's not very important. If it's a tiny prototype, I would ask a very junior person to come to me, look at my code or look at my feature and say, what is that? How does it work? And if they say, it's simple, then I would say, okay, if like nothing will grow out of this prototype, probably it doesn't force it to invest time in testing right now. But if they struggle with understanding what I've coded there, then probably I will ask them to write tests, because they also need to have some experience, gain some experience, and also they will understand better. And I would have tests, and then I will continue with the TDD approach. because it's like in maybe 80% of the cases, it's not just a prototype. It will grow in a real application. So this question I want you to ask yourself when you start on something. It doesn't matter what, data related or not. So please ask this question. And remember this meme, not just because this child looks like me in the age of 3, but just because disaster can happen when you don't test your things. So thank you so much. Please, if you have any questions.